You ever just stop and think about the crazy tech that's hidden inside stuff we see every day? I mean, take a medical needle. Looks simple, doesn't it? But really, it's this piece of high-precision engineering where, failure is just not an option. So, what's holding it all together?
That's a really good question, and honestly, the answer is kind of fascinating. It's definitely not just a little dab of glue. We're talking about a super sophisticated chemical bond, and the science behind that bond is what keeps millions and millions of us safe and sound.
Okay, so every needle basically has two main parts. You've got the long, skinny stainless steel tube, that's called the cannula, and then you have the plastic base that you hold onto, which is the hub. And right where those two things meet, that's where this specialized adhesive comes in. And believe me, this isn't just a simple connection. It is an absolutely critical safety component.
I mean, just think about that for a second. This tiny bond, it has to put up with all the pulling forces when it's being used and never ever fail. And that's not even the half of it. Before it even gets near a patient, it has to survive these brutal sterilization processes. We're talking high-pressure steams, sometimes even radiation, and it can't weaken one bit. The stakes, yeah, they couldn't be any higher.
All right, so where's the real challenge in all this? Well, it's not about making just one perfect needle. The trick is making billions of them, and every single one has to have that same perfect consistency. Because when you're working at that kind of scale, even the tiniest little inconsistency can blow up into a massive problem.
Yep, you heard that right. Billions. Every single year. With numbers that big, you just can't rely on someone checking each one by hand. It's impossible. So the manufacturing process itself has to be pretty much flawless. The margin for error is, well, it's basically zero. And this is exactly why the choice of adhesive is so important.
And this is where we meet the main villain of our story, latent bond failure. It's this hidden weakness you see that might not show up right away. You can think of it like a ticking time bomb, a failure just waiting for the wrong moment to happen. And it's a huge risk with older technologies, especially those traditional two-part epoxies where you have to mix them perfectly every single time.
And this quote here really just nails it, doesn't it? Picking the right adhesive, it's not just some small technical choice. No, it's a strategic decision. It's all about designing the risk completely out of the product, right from the get-go, to protect patients and make sure the whole manufacturing line is totally reliable. So, if the old-school epoxies are the problem, what's the solution? Well, it's this really elegant and powerful technology. We're talking about UV curable adhesives. This is the modern, high-tech answer to all those risks and all that inefficiency from the older ways of doing things.
It honestly sounds a little bit like magic, right? You've got this liquid adhesive that you can put down with perfect precision, and then boom! You hit it with a targeted flash of light, and it transforms, almost instantly, into this super strong, totally solid plastic. There's no waiting around, no messy mixing, just a perfect, powerful bond created exactly when you want it.
So what's the actual science behind this? Well, it's a process called photopolymerization. Here's how it works. First, the liquid gets applied exactly where it needs to go. Then, it gets blasted with a very specific wavelength of light. This light flips a switch on these special molecules called photoinitiators, and they kick off this massive chain reaction, locking all the polymer chains together tight. And the best part? In just a few seconds, you've got a fully cured, unbelievably durable bond.
Okay, so just how much better is this new method? Let's do a little head-to-head comparison. We'll put the modern UV curable adhesives up against the old-school two-part epoxies and see exactly how they stack up.
So in one corner, we have the old guard, the two-part epoxy. It totally relies on a chemical reaction that only happens after you mix the two parts. And in the other corner, we've got the modern solution, a single-part UV adhesive that cures with just a flash of light.
All right, now this is where things get really interesting. Take a look at the row for technical risk. See that? For the UV adhesives, it's low. But for the two-part epoxy, it's high. And that's all because of those potential mixing errors. Now, let your eyes drift down to leaching risk. That's the danger of unreacted chemicals leaking out of the bond. For the epoxies, it's high, but for the UV stuff, very low. I mean, that is a massive win for patient safety. So here's the fatal flaw, the real kicker. With a two-part epoxy, a tiny mixing error, we're talking just 2% off, can cause an incomplete chemical reaction. What does that mean? It means a weaker bond. And even worse, it means there's a real potential for those unreacted chemicals to leak and mess with the device's biocompatibility. A UV adhesive, it just eliminates that risk completely. Why? Because there's no mixing to mess up in the first place. And then you've got the speed.
Honestly, this chart says everything you need to know. We are talking about hours for the traditional epoxies to cure versus mere seconds for UV adhesives. That isn't just a small improvement. That is a complete and total game changer for manufacturing. And that incredible speed, it creates this awesome domino effect of benefits. Your production throughput just skyrockets. You can get rid of these huge energy-guzzling ovens, which saves a ton of money and a ton of factory floor space. On top of that, they use way less energy and they don't have any of those nasty volatile organic compounds, or VOCs, the harmful chemicals that get released into the air, so it makes them a much greener choice all around.
When you get right down to it, all of these technical perks, all these manufacturing advantages, they all point to one single crucial thing: creating a safer medical device. Because at the end of the day, in this industry, patient safety is the only metric that really truly matters.
So look, these advanced adhesives aren't just strong and fast. They are proven to be medically safe. They pass the world's most rigorous international standards. We're talking about things like ISO 10993 and USP Class V. To put it simply, these certifications are a guarantee. They mean these adhesives are non-toxic and they won't cause any harmful reactions when they come into contact with the human body. And you know what? They hold up. That bond stays perfectly stable and strong, even after getting hit with the most common and frankly the most harsh methods of medical sterilization. So whether it's high-pressure steam in an autoclave, a blast of gamma radiation, or ethylene oxide gas, that bond's integrity is not going anywhere.
So when you put all the pieces together, you realize this is about so much more than just picking a better glue. Making the switch to these advanced UV-curable systems, well, it's become a fundamental requirement for modern medical device manufacturing. It's a straight-up upgrade for patient safety, for production efficiency, and for overall reliability.
It really gets you thinking, doesn't it? I mean, the science packed into something as simple as a needle bond is this complex and this critical. So what other invisible innovations are out there, hidden in plain sight, working around the clock to protect us and make our lives better every single day?